think that one's also no.
Nope, it's open.
All right, so you need split screen on a big computer if you have it. If you're working off your Chromebook, that's fine. Split screen won't work very well. And you're going to POE Distance Learning Lesson 1, 2, 3. Distance Learning Lesson 1, 2, 3. And your split screen, you're going to your Tinkercad account. And then you're clicking Designs. You're going to click Circuits. And you're going to click New. And you're going to click Circuit again.
This one has a switch, but no breadboard.
The switch. Just get the switch.
Yeah, I'll keep that.
So remember over here on the right-hand side column is your basic components. Right at the top is your search bar that says Find Components. Darius, does that help out some, moving those desks like that? Okay.
There's only old Raspberry Pis in here.
You can change, if you click the drop down up in the little components menu. Let me see if I can make this bigger for you. All right, how's that? Is that a little bigger, a little better? Split screen, you pull out the tab, and move it over. And then you resize them to make them side by side.
Yeah.
Wow, it's magic. All right.
There's only new ones in here.
There shouldn't be. There should be. The new ones are in those, and they were at the bottom.
Yeah, we only see.
Yeah, only new ones in here.
Only new ones. Well, they may not have been used. Not all of them. So. 1, 2, 3 distance learning. DL. DL 1, 2, 3. So in your component screens, remember in your component screen right here, on the right hand side, there's a little box and it says components and it says basic. If you click that drop down, you're going to get different choices. So basic, all, and then starters. There's basic, Arduino, microbit, circuit assemblies, and then all. Okay, you just need basic right now. But there's a lot of different options. So just as a side note, if you want to learn more about Arduino, then they give you, which you will, or you could get some distance learning lessons that I assign you, some lessons that are going to involve Arduino. Okay, and Arduino, for when we start using the STEM Lingo kits, Arduino chipboards are in the STEM Lingo kits, okay? But we're going to go back to basic. All right? So we need to name this. Let's scroll down right here. POE 1, 2, 3 electrical circuit simulation. Put your name in there. Okay, so if you want to do your name first, that's fine. As long as your name is in there someplace. Up there in the top, right next to the little Tinkercad box with the 9 squares that spells out Tinkercad dashboard, click that goofy little name that it randomizes for you. Right here, honey. Number 8. Number 8. That's why you need a side by side. Rename, but I need you to add your name to it. And then hit enter. So, Diamond, if you look up at the screen, see when I put the pointer right over this? It says change name? Okay. All right.
We need 6 more.
I had like 15 kids in the case, but that's all right. So for your component options, select all. So come over to components, select all. You guys ready? There's a lunch bell.
You said they were in the case.
They were in that cabinet.
I sure didn't move them.
No, they were in that cabinet. So how many did you have in that cabinet?
2 old ones.
Yeah, but the rest are new. There's some in there, but they're new ones.
Look at some of those pencil cases and see if they got put in there.
I checked all of them.
Okay, so you're going to scroll down and select a 9-volt battery. So this is number 10. You're going to scroll down in your components. The other thing you can do also, there's our 9-volt battery. If you're not sure what you're looking for, you can just type it in here. So let's say that I didn't know what I was looking for and I didn't select all, and I could do 9-volt. Then it's going to tell me, and then it knows that I want a 9-volt battery. So I'm going to select a 9-volt battery. There's my battery. You can change its name. So it's just battery number 1. Okay. So here's our name. We just changed the name of that, battery number 1. So now number 11. Add a multimeter component to the workspace and connect the multimeter to the battery terminals. Let's select multimeter. So here's our multimeter right here. Yes, this looks different than a handheld multimeter. Okay. So we can change that name if we want to multimeter number 1. So right now it says for B, select start simulation and note the voltage. So if we hit start simulation, look at that. It says we have 0 volts. Anybody want to tell me why we have 0 volts? Exactly. It's not connected to the battery. To stop the simulation, you just click stop. Oh, check your response. There's a big, long response.
Can we use the Jesus from the review boxes? Can we use the Jesus from the review boxes?
Let's say we want to turn this guy. We don't like him going that way. Right here, toggle the code editor. Nope, I don't want to do that. I don't want to go back to that. I'm hitting the wrong one. It's because my screen is so big. Let me open this up so I can see. So see this right here? It says rotate or R. So if you do Control R, or if you just do R, capital R, it'll rotate that. Just by clicking and holding, moves your items. Yes, ma'am. Okay. Okay. So we want to draw from positive to positive. So where's our positives? What color are our positives? Red. Very good. Thank you. Okay. So we're going to take right here. Now that's a green line. How do we change our green line? Right here. Got it? Okay. So then let's make a negative to negative. But wait a minute, that's still red. Let's change that to black. Match your colors so that there's little, if any, confusion. Okay? Because when you physically are wiring something, you're not gonna it's not gonna work. You can blow it up. Okay? Believe me, I've blown up many an LED, and I'm still blowing them up. All right. So if we hit start simulation, 9 volts. We have a 9-volt battery. Our multimeter is telling us we have 9 volts. What if we messed up and we what would happen? Nothing. We got too many wires. So if we accidentally ran positive to negative and negative to positive, what do you think would happen? What if we ran our positive to our negative and our negative to our positive? What do you think we would get? -9, because we've crossed our voltage. That's bad. We would have just blown something up. We just kind of blew it up. So let me move this back over there, and let me do that. Okay. All right. Minimize this. So in this number 12, it says interrupt the circuit schematic in figure 4 to model the circuit in Tinkercad. So how do you think what would we do? So we have our 9-volt battery. We're going to add a light bulb, a slide switch, and multimeter components. So let's go find a light bulb. Oh, come on now. So here's a light bulb. Let's grab a light bulb, drop a light bulb. Okay. We've got our 9-volt battery already. We need a slide switch. So let's look for a switch. A slide switch. There's a slide switch. Okay. And multimeter components. Connect the components using your wires. This is a diagram here. This is another reason I want you side by side so you can see that diagram. So this is what it needs to look like. So we have our 9-volt. Okay. Our ground goes to our light bulb. So let's get rid of this ground and move it. This goes to, and look, when you're doing this come on. Go back. There we go. So let's delete that. Let's delete that. So our diagram shows us that we go from ground to one side of the light bulb. So ground, click to our light bulb. I like neat wiring, sorry. And then our ground from our light bulb okay, I'll wait a second. Okay, our ground from our light bulb to our ground on our multimeter. So we can actually move our multimeter. Let's move it so that it's in a better spot. And then our switch needs to be over here according to our diagram. You can tune your battery any way you want to. You can turn your light bulb any way you want to. Okay, so now we need a wire from our light bulb. Whoop, stop moving, light bulb. I don't want to move you. So let's go here from our negative from here. Come down a little bit, come over. Attach that there. So now we need a positive. I'm going to change that to red so I know what I'm doing. Come down. I'm going to come over a little. And then I'm going to come up to the positive of my light bulb. And that's from our multimeter. And I'm going to follow along with what PLTW is showing. So I'm going to do a green. And the green comes off one side of the switch. And goes to our light bulb terminal. Now, if we ran simulation right now, what would happen? Nothing. Why is nothing happening? Why is nothing happening? Have we connected our circuit? What's missing? Oh, come on, guys. What's missing? Is there any power getting to any of this? You got power to yours, but just mine. Is there any power getting to the light bulb? You got to connect. You got to connect your positive. There we go. Now, if we started the simulation, what would happen? Nothing. What if we flip the switch? Woohoo! And look at our power, 8.73. Now, why is our multimeter, if we have a 9-volt battery and we ran our 9-volt battery to our multimeter and our battery read 9 volts, why, when we turn the light on, let's turn the switch off, why does it now say 0 volts? And why does it now say, when we turn the switch on and turn the light on, it now says 8.73 volts? Where's that other 0.27 volts going? What's happening? Anybody? Just take a wild guess. What's happening? Huh? Well, you're using the battery. The battery has 9 volts, but why is not 9 volts being read on the multimeter? What's in the way using energy? Who said it? Yeah, the light bulb. The light bulb is in the way using energy. So right here, this guy, this dude right here, okay? He's in the way using energy. So it's coming from here and going to the switch. The switch is also using energy. And then the switch is transferring what it receives to the light bulb. And then we're reading what the output is on our multimeter. All right, so record the voltage measurement across, so what was it, 8.73? Put that in on, well, we got to make sure we put our V in there for volts. Check our work. Yeah, that's what it looks like. Kind of different, mine's laid out, straight like this, but so 13 to close the circuit. And by the way, when I want you to diagram this in your PLTW notebook and write what the volts were. Okay, 8.73 when the switch is turned on. So 13, to close the circuit and illuminate the light bulb. Remember, it's a closed circuit because right now it's open. It's open, it's free, there's nothing going. But we have to close the circuit. Okay, we have to close the circuit. I really dislike that pop-up coming up every time. Gets in my way. All right. To close the circuit and illuminate the light bulb, set the switch to the on position. Check the voltage across the bulb, record the voltage. So that's right here. Sorry, I told you to put 8.73 in the wrong spot. I got ahead of myself. That happens all the time. Y'all know that. So start the simulation with the switch in the off position. I moved my switch. Switch is on, switch is off. We have 0.00. See that little stripy line right here in the switch? See a little stripy line? Click that. And then click that. There you go. So this is off. This is on. Huh? Oh. So in 14, it says stop the simulation and move the wire connections to the voltmeter to measure the voltage across the battery. So let's stop. And we just want to move our connections to the voltmeter. That involves deleting some wires. So we're going to take this from here. We're going to pull that out. Oh, come on. No. Oh, I know. So then we're going to change your wire color to the correct wire color. So we're going to go negative. We're going to click and we're going to go straight up. Sorry. I just happen to like straight wires. I don't like crooked wires. Change our wire color to red. When I was taking my training in this, my instructor would take points off if I did not have straight wires. All right, so now what else? What does it say to do? Stop your simulation and let's just go to the battery. So let's check now. What's it say? 9. So is why is the reason again that we're getting it's 9-volt battery and we're getting 9 volts? Because there's nothing in the way. We're not interfering with anything. There's nothing else we need to power. We're just checking the power of the battery. All right, we recorded our voltage. Let's check our work. Ooh, look at that. It's got more wires coming out the other way. So let's see. Let's duplicate what we have here. So let's take another positive. Let's get another positive. You got to get that little thingy like that. It is a whole lot of wires. You got to do it like, uh-oh. No phones in class. Thank you. Now let's change this to black. And now we need to run our black. Run another black wire up. And again, yours can be laid out any way you want to. This just happens to be how I'm laying mine out. And now let's run the simulation. 8.73. So did it make a difference did our output make a difference from running both our leads off our positive and our negative on our battery and having one pair going directly to the voltmeter, or how we had it before? Why did the output on the battery not change? Why did the voltmeter not change? Because why? Right. It's not being added in the same, and it's still going, the power is still going to the switch and still going to the light bulb. It's still going to the switch and the light bulb. So when we turn the switch off, we're still getting 9 volts because there's no power going to anything. We're just reading it. But when we turn the switch on, 8.73, it doesn't make a difference if we have the positive run to the light or the positive run directly to the switch rather, and then have it run off the switch and go to the voltmeter. All the voltmeter's doing is reading it. It's not interrupting the flow of energy at all. Okay, so record the voltage measurement with the bulb off. Well, there's no way to record it with the bulb off because nothing happens, you know. All right, so it's still running 8.73. This is the diagram. This right here is the diagram of what happens. So when the switch is off, this is a symbol for the switch being off. This is your symbol for the switch being off. It's up. It's not making a connection. Okay. Hi, everybody. Ooh, I see you brought coffee. If you need a refill, I have a Keurig back here.
Thank you. I gotta do one. I'm okay right now.
I'm up to one of these every class period. Okay. Okay. So now do you remember what this switch, what this symbol is? The battery. Very good. And of course, this looks like what? Our light bulb. All right. You should have this in your notebook. Remember when I made you sit down and just sketch one day? Yeah. Okay, so let's run this guy again. So what's going to happen when we run the simulation? Somebody tell me. Let me turn the battery off, or I can't yet until I run the simulation. There's nothing, our switch is open. There's no connection. There's no way for the power to circulate all the way around. Okay? All right. Why again did I have us do the simulation again? Any ideas? Because you're going to try it for real. Because you're going to try it for real. What I want you to do is take a look at the next steps, starting with creating a series circuit. Your breadboards. I have enlisted the help of 2 of my former students to come in and walk you guys through and give you some more help since we got company today. I would ask them to come down anyhow. These guys are awesome. I'm going to cry like a baby when they graduate because when I am. These are my freshmen. When they were freshmen, I was a freshman here. So, yeah, I'm gonna a proud mom moment, So, yeah, yeah, and Cortez, you got a full ride to someplace, didn't you?
I got a full ride to Harrisville, but I don't.
To Harrisville? He's not sure. Yeah, but yeah.
The most I've gotten from scholarships was $25,000 a year to go to SLU.
Yeah.
Which is
Yeah. And Cortez has been through all 3 of the engineerings, and he did computer science with me last year. Isaiah's been through all 3 of the engineerings, and he's doing computer science with me this year. So, yeah, they're some of my babies.
Babies. Babies.
Yeah, there you go. Yep. All right. So I know you guys have questions for the kids too. You want to talk to them, and pardon my mess, but
This typical engineering class.
it drives me crazy. My grandfather worked for Panhandle Steel, and his workshop in the basement of the house and in the garage everything was in order and it was immaculate. I got used to it. My dad, amateur woodworker, but built some beautiful things. Same thing.
Yeah.
Everything. So
And
this
then
still
here's
drives me
your-
nuts.
here's
I
your,
know, and
favorite-
and Einstein said.
Everybody always
Einstein
letting
said.
us know. I was so excited to get to see you today. It's been a long
My
time.
gray one's out in the car.
Oh, there
My
you
blue
go.
one's filthy dog.
Honestly, if I could, I'd probably take it.
I know.
I'm excited to be here.
I am
It was hard.
I still have my hair.
I
mean, you got it.
No,
The soldering and the breadboard. I actually still have my portfolio. And I did this. It's really fit mine. I don't bring the school because I like to laugh. Let's go in there.
No, just like this time at your campus, I had no idea you guys had
Computer science and
exterior
algebra.
building models.
Oh, yeah.
All that.
Yeah,
No idea.
it's set up like a college.
Yeah, it's awesome. It's awesome. I love it.
Well,
Okay, so that wasn't your first, that was your first year. What's your second?
yeah, not what grades, but
I would
yeah,
say
I
this,
have.
like,
I
in
mean,
argument,
I'm highly
POE was on this.
Right.
So like what they're doing now. we need to-
So yeah, let me stop recording.
Gotcha.
Yeah.
So we'll probably go to input.